Hello everyone. This is a demo of Lab 5, which is about using an intrusion detection system, Snort. Okay, so in this lab, we will use IDS, we use Snort to give us alert about certain anomalies in the network. So as we did in the previous lab, uh, we're going to go over some of the principles, some of the ideas, and then we'll get into the details. So, as we mentioned in class, IDS systems can be deployed either inline or out of band. So, when we use it out of band, you can imagine that we have a network. I'm going to make a simplified network. So let's say there's a firewall here, and then the firewall is connected to a switch, and the switch is connected to hosts. That could be my network. And I may attach an IDS system here to the switch. So in order to pass traffic to the IDS, I need to have a port mirroring in this port. So in port mirroring, all the traffic that's passing through all other ports will be copied to the IDS. So this is how the IDS will see traffic and do its thing, right, to process that traffic. We need another link. In your lectures, you see something that dashed lined here. So this is another link that will connect it to the administrator. The administrator may have one of these nodes as, you know, a way to connect to the IDS and configure it. So IDS needs two ports, one for the traffic and one for the administration, at least two. Okay, so we're gonna do the same thing here in this lab, and we're gonna use Snort as IDS system. Snort is one of the well-known open source IDS systems. It started as open source project. Now it is bought by Cisco. It's still open source. You still can download it freely and use it. Cisco just the guardian, let's say, of this project. So they're giving it for free. But there is also on top of it there is a layer of service that Cisco provides that's paid for, right? So there is a part that's commercial, but in general, so Snort is free, open source. You can download it and use it, and this is what we are doing here. But we're doing something else in addition to this configuration. Rather than using a traditional switch, we're going to use an open flow switch. So we're going to use software-defined networking here. So in addition to that, we're not going to use firewall. We're just going to simplify the network further and use uh, this uh, this topology here. So with this topology, we have the open flow switch that we have seen in previous lab. We have 4 hosts. We have the controller for the open flow switch, and we have the Snort application. All of this is in your virtual machine. So all of this, as before, the switch and the host is emulated by Mininet. The controller software is running on the virtual machine, and we also will run Snort. Okay, so um, as I said before, two we need two ports here to connect to the IDS. So what are the two ports? You can connect port to the virtual switch, the OpenV switch in your Linux box as any other ports. But instead of that, we're going to use um, a special port on the OpenFlow switch is called local port. The local port is a special port uh, that is used if I want to send something to the switch itself. Right? So what we'll do here, port mirroring, um, instead of port mirroring to an external switch, we are going to send all the traffic that's passing through the OpenFlow switch. We're going to send it to the local switch. The local switch will be, or the local port, I should say, will be connected to Snort. Okay. How about the management link? We need another port to do management. That will be using Linux sockets, right? So uh, uh, different processes inside Linux can talk to each other over Linux socket. So we're gonna simulate the whole process by sending all traffic that goes to or through these ports to the local port of the switch, which is connected to Snort. So Snort will be monitoring the local port and will be copying or seeing anything that goes to the switch. And also the controller, the SDN controller, and the Snort will be talking over Linux socket. And this is how we will build the scenario here, the hardware scenario. Okay, so this is a normal or this is one way to implement or integrate Snort with software-defined networking. So the next question will be why we're doing this. Why we don't just use a regular switch, standard switch that you're all familiar with, and connect uh, SDN or Snort to it and do port mirroring? Well, two reasons. First, it will be more involved if we use a hardware switch. It would require more work, and it's easier just to use the virtual machine to do everything. But there is more important reason. The more important reason is we're going to use the software-defined networking to turn the IDS Snort into an IPS. By the way, Snort by itself has some IPS capabilities, uh, even without using software-defined networking. It can block some of the traffic, but we're going to use the capabilities of software-defined networking to make sure that, or to turn a regular Snort into an IPS. One of the things that we cannot do in regular Snort, if we connect it through like this in out of band Snort cannot work as IPS because it doesn't have the capability of blocking traffic. It just sees the traffic. It's not in line with the traffic. You have to be in line with the traffic to be able to block anything. But in this scenario, or in the scenarios that we have seen, just the traditional one, when it's connected to to a port and using port mirroring, it cannot block anything. But here we're gonna let Snort tell the controller to block traffic. So every time Snort gets an alert or decides that, well, this is suspicious traffic, it will send an alert to the controller and say, hey, I saw something. And the controller will block the traffic. So Snort and the SDN controller will work together as an integrated IPS system. Right? And when I say the controller, again, for probably the 100th times, I would say this, and you will be hearing me saying it over and over. The controller is not what it does. What it controls the network. The controller is just an operating system. What controls the network is actually the application. So we will be using two applications today. One is similar to the one that we saw in the previous lab. So it will do the switching, and the other one will give us a GUI. So before I get into that detail, let's start by looking at actually, how about we'll talk about the detail of the of the application right now. So which is mentioned here in the first task, task one. So to get an idea about what the application, software defined application work, um, I'm going to remind you of the previous demo or of the previous lab. But if you haven't seen that or you don't remember, so here is the quick reminder. So what we did last time, we um, used OpenFlow switch with, I'm gonna try to make it as accurate as possible or as clean as possible. So we used OpenFlow switch with two OpenFlow tables or flow tables. And if you don't remember what that means, please go to the previous demo and look at it to understand. So the here two tables, table 0 and table 1. Last time we used table 0 as our access list table, okay? And table 1 to do the actual uh, passing of packets between nodes, right? In our case here in this lab, we will use table 0 for a much simpler function. So one port connects to the controller, and we have a running application here on top of the controller. That's what we will use. And we have 4 nodes connected to the switch. So in this table, in table 0, what we will do is say any packet that comes. So we have seen that we have priority, we have match, we have instructions. So we'll say any packet that match that comes into this table, we're going to do two things to it. The first one is we're going to send the packet itself to the local port. So we'll send the packet to the local port. Why? Because this local port is monitored by uh, by our snort. And we have another output instruction here that say, or actually not output, it's something called go to, another instruction go to table 1. So you see two instructions here. The first one sends a packet to the local port, which is monitored by the snort, and this is equivalent to port mirroring. The second instruction will send it to table 1. Table 1 has another entry that says if it doesn't match any specific entry here, send it to the controller. This table will work exactly the same as previous lab where it sent the packet to the controller maintains MAC address, MAC table with the MAC and ports, and when the controller learns about both the ingress port, no, I should say when the controller or the application learns about both where the packet came from and which port is going to, it will send the packet. It will send an instruction here to forward the packet accordingly. So please go back to the previous uh, lab demo to see how that works. I'm not going to explain it any further here, but you will see here that we are using a different application than the last time. So this application will simply uh, take the packet, duplicate any packet into two. One goes to Snort, one goes to the second table to be able to or to be processed by the uh, uh, the software-defined networking application. Okay, so that's the explanation here in your notes. So what I will do, I will log into the VM and I will start Mininet, and then I will start the controller, and uh, and we will run. So we need how many terminals we need? We need 3 terminals this time. Okay, so it will be a little bit tricky to navigate between 3 terminals. I will use one terminal for the Mininet. I'll use another terminal for the software-defined networking, the SDN controller, and use third terminal to start and stop Snort. One more note about Snort. Snort usually runs in the background, right? So when I start my server, it will run in the background. What we will do here, we disable this capability and we will start and stop Snort manually, just to make sure that um, we can change the configuration and enable the latest configuration every time we run Snort. Okay, so now I'm logged into my terminal. I will start by running Mininet. So here we are, SDN, and then we'll run this Python code that will start Mininet and create a switch and 4 nodes. Okay, so if I do ping all here, it won't work. Why? Because now we started software-defined networking switch, OpenFlow switch, and the OpenFlow switch will not be able to work unless it gets some instructions from the controller. So we're gonna go to another terminal and I'm going to run the controller. The controller, this shell script will run the controller and the GUI application together. I'm gonna add on top of that this application is called Learning Switch Snort, which will help me. Which what I described here, it has two tables. Okay, if I switch back to Mininet and do ping all again, that should work. So what happened? Now the controller started, talked to the switch, applied the flow entries that we talked about earlier, and started learning about nodes and started passing traffic. If I go to my browser and direct my browser to the VM address, I see here there is one switch, switch 1, and if I look at the flows, I see these tables. If I ping again and refresh, you will see that now the switch learned about all the destinations and all the sources here. So this is like last time. The table 1 is like last time. No change. But table 0, last time we used it for access list. This time it has one function only, which is, as I said before, if you look at this part, the instructions, output to local and go to table 1. Okay, so this is what I talked about earlier. Now this completes task 1. If you continue from this point on, you will just notice a normal layer 2 switch. There is nothing different than a layer 2 switch. We didn't actually even start snort yet. So let's go back to task 2. We're gonna introduce snort here. Okay, snort, aside from the open source part that I talked about, relies on user defined rules to do its work. So it has a lot of rules, and you can go back to the, the lectures and revisit what we talked about in IDS. Some IDS systems detect rate anomalies, statistical anomalies, all of that things that we talked about, so I'm not going to repeat it. And some of them use rules, right? This one, you can use the rules to do many of the things that we talked about. So where are the rules? If I go now to the third terminal, this is the one that I'm going to dedicate to snort. And where are the rules? So I can use the command less. I may need sudo, but I will try it without it first. /etc snort rules. Actually, maybe I'll do ls. So here are all the built-in rules that come with snort. Something called community bot, community deleted, exploit, FTP, game, all of that things. If I look further to one of these, let's pick one of these and look at them. And let's say community web attacks. You see there are rules here. It says alert TCP external net any to HTTP servers, HTTP ports. This means that from an external network, any port to HTTP servers, HTTP port, which are 80 or 8080 or whatever, if you send this message, community web attacks, etc., etc., if you see some of, so here, if the content is this, and this is the signatures that we talked about. So I mentioned that there are certain signatures that the IDS will look for in a packet, and if they see them, they will send an alert, or the IDS will send an alert, IPS will block. So this is one of the rules. It says if you see the signature, and actually I haven't seen this before, so I may not be accurate in the description here, but you see all of these rules talk about the same concept. You have an alert message, and then you have parameters, and the parameters say what is the alert is about, when do you send the alert. Let's see another. another example, rules, DNS rules, and you see another set of rules. For a message here says DNS exploit named, etc., etc. So this will detect a known DNS exploit, and it will alert for it. So what we will do here is we will write our own rules, right? We're not going to use all of these rules. We're going to write our own rules to just to gain more understanding. So let me go back to snort configuration file, and in this case I probably need to use sudo. So with snort configuration file, I disabled all of these rules. If you look at, I'm not going to go into all of these details, but a lot of these rules were disabled. So the only, I have to go down to see all the rules. You see here all of these rules, and there's the hashtag, so that's the comment in the configuration file. So all of these are commented, so they're not active. If I go at the end here, let's use tail instead of less, and so the last line in the configuration file, it says include, this is the rule path, my rules.rules. That's the rule that I want to use, right? Only my rules. So what is in this file? Before we take a look at it, let's enable, let's start snort. Okay, so to start snort, we need to apply these two lines. First one, it will activate the local port on the switch. Usually it's disabled by default, so I want to turn it on, and this is the local port on the software, on the OpenFlow switch, and it's connected. It will act as a mirror port for snort, so I want to activate it first. So I'll do sudo you can copy and paste, but I'm not going to copy and paste here. And next I will start snort itself. In the documentation there is an explanation for each one of these options, but the first option tells me what interface I should be looking at, which is switch 1. It's called switch 1 here, and then I'm gonna direct all the alerts to the console, right? So all the alerts right now, I'm gonna see them on the console, in the terminal, and there are certain logs that will go, and files that will go to the temporary directory. We will see some of them, and the temp directory or the folder in Linux, it is deleted every day automatically by Linux, so nothing there stays permanent. And finally I will direct snort to look at the configuration file. So now I'm running snort, and I think I made a mistake, so instead of sudo I put n instead of u. Alright, here we go. So now snort is working. Snort is doing something based on the rules that I put. So what are these? Let's go back to my previous terminal and ping. Let's ping h1, ping h4. Ping continues normally. If I go back to the browser, you see I am pinging between node 1 and node 4, so other entries expired. So the only entries that are active now is these two entries. And you'll see here the packet count in table 0 is increasing. Every time I refresh, it's increasing because there are more packets are passing, matching this entry and going to table 1. Okay, back to my terminal. Ping continues. Everything is normal, okay? So now I'm gonna change something. I'm gonna make the ping goes a little bit faster by changing the intervals between pings to 0.4 second. And I'm gonna run this. Let it run for about 10 seconds. And then go back to this entry here. See, here we started to get alerts from Snort that says denial of service attack. ICMP 10.1.1.10 to 10.1.1.40. So it sent us a denial of service attack. Why? Because one of the rules that I put here says that if ping is going faster than normal, or we have a rate higher than normal, send us an alert, right? So let me repeat this. I'm going to send normal ping. Okay, let's take a look at the second terminal. There is no more alerts. It's quiet. Okay. Let's change the interval and make it faster. Go back to, it will take about 10 seconds and then we'll start seeing here, we start seeing alerts coming. Why? Well, let's take a look at the rules that we skipped earlier. Maybe we'll start stopping the ping and we'll stop snort as well. And here is a hint. If you do Control C to stop snort, snort will take a long time to stop. Right? So you will be waiting for a long time. So what you need to do to encourage snort to stop is to send maybe another ping. Now it stops, right? So create some kind of traffic in the switch and snort will stop. So put Control C and then go to Mininet and ping any two nodes, any traffic. So it will, I think snort will get an input and start saying, oh, I have another input, which is the Control C, so I'm gonna stop. Okay, if you stop snort, you will see all of these statistics. It's the report, and you may see some data. We're not gonna take a look at all of this right now. right? But you can um, analyze it if you want. So Ethernet packet received is 543, IP packets for IP4 packets received 521, ICMP packet 521. So you can see some data, some statistics. By the way, Snort has one great uh, disadvantage, which it doesn't come with a GUI. The GUI is all command line. Well, it's not a GUI, but the access through command line. So it is a little bit hard to get, to interact with. So there are third-party GUIs. So other open source software is available there to be integrated with Snort. Snort itself doesn't have one. Okay, so we'll go back to the notes here and we'll say read the log file generated by Snort using TCP dump. All right, so we'll do that. So we'll go back to terminal and do sudo TCP. So what I mean here, the TCP dump, the Snort will generate log files in a TCP dump format, right? So we're not doing an actual sniffing of the traffic. We're just reading a file generated by um, Snort in a TCP dump format. So the -r here just means read from a file. So when you start, there is only one log files in the temporary, but as you go, you have to look at which one is the last one, okay? So right now, I have only one log file. Just to let you know, let's do ls and then temp. I may have more than one log file in this case. Oh, let me see. Yeah, so I have only one log file. As I said, anything in the temporary folder will be deleted every 24 hours. So there are a number of files. I'm just interested in one of them. So these are what you see here are the messages or the alert messages or the messages that generated the alert, I should say. Okay, so we're gonna move on and see after this is the rules that generated this. So why we got the alert in the first place. So if we go to the rules, etc snort my rules or rules, the folder is rules, and then the file itself is my rules, and take a look. I'll see that my rules here says alert ICMP traffic from any IP, any port to this host. We'll assume that it's a server, any port, and then the message that we're gonna send. So if my traffic matches this entry, send a message. It's a denial of service attack. If these conditions match, so what is the condition? The condition is we have a number of packets that the count is 19 within 10 seconds. If I see 19 packets within 10 seconds, I would say, well, this is not normal, send an alert. Okay, so this is something that we created ourselves. We can say, we can change the count into 25 or 10 or so. In this case, every packet, or to have a 19 packets within 10 seconds means that the interval between one packet and another is less than 0.5 seconds, which what we did earlier, we sent packets with the interval 0.4. Right? So what does that mean? It means that I am creating a rule that says if you see an increasingly fast ICMP, this may not be a regular ICMP packet that may be generated by the network management system or something that maybe just checking on the status of the network. This could be a sign of an attack, right? So send an alert. Okay, let's continue. So what we did so far, we just send an alert to the console. We will now send the alert to the SDN controller. And we'll see, or well, we already wrote the software so that it will interact or will receive the message from Snort and will stop the traffic. Okay, so what we will do here, change our output of the message to the socket, Unix socket here, which is attached, which is our software-defined networking controller is listening to the socket. So if it receives the message through the socket, it will change uh, the, the flow entries in the switch and it will stop the traffic. Alright, so I'm gonna go back to my terminal. Ping here is still continuous, so I'm gonna stop it. I forgot to stop it earlier, but no problem. I am going to start Snort, same as before, but instead of console, I'm going to send it to the socket. Okay, so now I started Snort. I'm going to go back to Mininet and I am going to ping between host 1 and host 4. Ping will work fine, no issue here. Okay, let's try something else. Let's try ping between 2 and 4. Okay, everything works fine. Our rule says if there is 19 packets within 10 seconds, send an alert. Here we have passed 19 packets already and 10 seconds, so we are sending a packet every 1 second. That's the default, I think, in ping, so there's no problem. So let's start, I'll change that and send ping in a short period of time, so the interval is 0.4. So you see here pings continue and then they stop. Okay, let's take a look. If I go to my software, to the controller terminal here, I will see a message that says alert message, DOS attack, IP version 4, destination 40, flags, da da da. So this is now I'm getting this on the controller. The controller sending they receive this message, not the console as before. So I'm just plotting or printing the log from the controller. So the controller received this. How did the controller react? Or how did the application react? Let's go to the browser and see what happens. The browser shows that we have message here, or we have an entry that says if you have um, a source 10 and destination 40, the ether type or the protocol is ICMP, drop the message or drop the packets. So the snort sent the alert to the controller. The controller, well, through the application, or said to the switch, stop these packets. So now we have an IPS system mixed or made from the snort and software-defined networking. And now we see that table 0 is being used as a way to block undesired traffic. Right. If I go back and go back to my terminal here and try to ping from two different sources, so let's say ping from port 2 from host 2 to host 4, that still continues normal, okay, because the blocking is only between host 1 and host 4. If I do this, if I create the same conditions again between 2 and 4, I will get 19 packets going, and then as soon as I reach the 20th, it will be blocked, because now we have 19 packets in 10 seconds. Okay, let's stop this one and see our browser, what happens. We have another blocked. So here from 10 to 40, here from 20 to 40 drop. So now somebody will say, well, how if I ping normal again, not fast, but just normal ping? Well, no, in this case, this will not change. So even if you go back and ping normal speed, you are blocked. Why did I do that? Or why this is just the code that we wrote. Okay, so I was trying to make it as simple as possible, so this will be permanent, unless somebody will come and say, well, here I'm gonna delete it manually. So you can delete these restrictions manually, and then if you go back and ping, you'll ping again normal. Okay, so the once you're blocked until somebody will go and delete the instructions manually. Okay, let's continue our tasks here. While we are before we go to task 4, let's see how the software works. Okay, so let's take a look at the software itself. So we'll go to the terminal where the controller is running. I'm gonna stop the controller right now, and let's visit, or let's take a look at the software that does all of this. So we'll use Nano SDN Learning Switch Snort, and so the if you look at the function, this features handler is the method or function that will send the initial flow entries to the table. And then we have here something called packet in handler. We talked about that last time. So this will receive any packets that coming from the controller itself, coming from the switch to the controller. The controller will forward them to this application, right? So this is not the controller. What you are seeing is not the controller. What you are seeing is the application that runs on top of the controller. But when the controller receives a message from the switch, it will forward it to any application that's running and that's listening to this particular event, right? So here it will process the packet. It has the MAC table as we saw last time, and it will send actions. Okay, so these are normal layer 2 activities. Here is the event, this process alert. This is the event that's reacting to the alert from Snort. Snort will send an alert to or through Unix socket. If the application receives that alert from the socket, will run this method. So here it will say if the DOS, which DOS is, if the DOS keyword in alert message, go and execute block DOS. And we'll see here another message called leak later. So DOS is just a string that was defined earlier. DOS equal DOS. So simply, it's a simple mechanism. I am sending a message, text message to the application. The application look for the text message and see if the word DOS, denial of service, in it. If that's the case, then what we'll do, it will call block DOS. It's in here somewhere, this one here. So block DOS will create and open a flow entry with these parameters, the source, this and the destination port and the IC. These are coming from the some of these are coming from the message itself, and it will send them to the switch. So the switch will stop the packets. Okay. Now let's continue with task 4. Task 4, you are supposed to add another rule yourself now. And this rule will block TCP traffic, or more particularly will block any files that has some sensitive information. Alright, so Snort or IDS systems in general has the ability to look into the content itself, not just the headers. So what we will do here, the concept is we will configure Snort to detect any specific keywords in any file that's being transmitted on the network, and if it sees suspicious, or if it sees certain keywords, it will block the file. So the message here, or the rule, says any TCP traffic going from 40 to any other node, that's the first line, send a message if the content has the word secret in it. no case, so it doesn't matter what the if it's uppercase or lowercase, and the flow is from the server to a client. Okay, these alerts, they have a lot of options. So by the way, I mean, we're not digging deep into what is the structure of these uh, or what is the syntax of these rules. This will take probably a course by itself if we want to go deep. But there are so many options. We just need to know that this means that detect the content and just alert. So we will go back to our um, snort terminal and we'll start snort. First we'll add this rule and then we'll start snort. So I'm gonna go back to terminal 1 just in case you forgot. I'm gonna start my controller again. Right? So don't forget to make sure that the controller and the application is always running, otherwise nothing will happen. Then we'll go to the other terminal, not the Mininet terminal, but the other terminal that has snort. We'll stop snort. It will not stop right away, so we'll go to Mininet and just send any traffic. That will stop snort. Okay. Now we need to edit the rules file. So sudo nano etc snort rules, my rules, and you can copy and paste if you want. I don't think indentation is significant here, so it's not like Python, but just for the clarity, make the indentation same. I will save this, and what we will do is start snort, but we'll direct the traffic to the console this time. We'll direct the alert to the console, not the traffic. The traffic will go to the switch and copy it to snort. Okay, so the word console is wrong. Okay, now it's working. So how can I generate file that has something secret? You can go to any other terminal. We'll go to you can choose a different technique, but I'm gonna stop snort again because I'm gonna use the same terminal to create the file. So before I start the snort, I'm gonna create the file first. So I'll create the file by using echo and write this. So echo will echo the message. This message will be saved in a file called budget.txt. Okay, you can use nano if you want, but I'm just going to use this term. The reason I stopped snort is because I want to use the same terminal for both. Okay, so now if I go and do cat or more budget, so what I did here in this terminal, I put the echo, and then now I'm gonna check. So now I have a file called cat. I have a file called budget.txt, and it has the content This is top secret information. Okay. You can create it from ManyNet itself, so let's remove budget from here. And let's create it through ManyNet, just in case you don't want to turn off snort or cancel. So you can choose any host. So say host 1 and then do echo. I'm just going to copy this. It will have the same effect if I say h1 cat budget.text. So I can create a file from within ManyNet, or I can stop snort, create the file, or stop the controller and create the file, then start again. All right, so any of these techniques, or you can start a new terminal and create the file. Any of this will work. Probably you haven't seen what I did before. So what I did here, I'm switching between terminals the wrong way. So what I did was create a file within terminal, within ManyNet, and then looked at the file. Okay, and so from ManyNet itself I did that. I'll go back to my snort terminal and I will start snort, directing traffic to the console. Okay. Now my note says here that I want to use NC, which is the netcat tool, to send the file from the server, which is .40 host 4, to any client, host 1 for example. So this line here, it starts a server on, so H4, that's the host, NC, the listen, this is how you configure a listening port on port 88, and um, whenever there is a request from a client, the the file will be downloaded, right? So again, NC is a very useful tool to be. You can use it to do a lot of things for testing, and rather than just always doing ping, you can use NC to do all sort of things. So we'll use it. We'll go to ManyNet and we'll start a server. The server will be doing nothing but listening to the request from a client, and as soon as that request comes, it will send the file. Okay, so now host 4 has a server that's listening. Now host 1 will send requests. So when it sends a request, it will receive that file. This is top secret information, so that the file will be sent. The content of the file will be sent. What happened to Snort? Snort is sending an alert that says data leak via TCP. Right? So Snort looked at the content of the file going, and it found the word secret. So it sent an alert. The alert showed up in the console. So according to the rules, everything is working fine. All right, so now we're going to do the same thing, but we'll send the alert uh, to the SDN controller instead of the console. So we're going to stop snort. Just send ping here, h1, ping h4, just so that we get quickly out of snort. And then we will run snort again. Notice this, the dash k none. I didn't do it previously, but in your notes you should be able to do it. This makes it consistent. Um, again, I'm not gonna get into the details of all of these options, but just make sure that in this particular task you have to have this option there for consistency. Otherwise, sometimes the alert doesn't come or is not issued. All right, so I'm gonna run snort. I am going back to I didn't switch, so apologies again. I forget to switch terminals sometimes. So let me show you what happened, what I just talked about. All right, so I am running snort. This is the dash k none that I was talking about, so make sure that it's there. It wasn't there before in the previous task because we didn't need it, but this one, make sure that um, um, the packet is um, the operation of snort is consistent. Let me put it this way. Okay, the details is beyond this discussion here, but just we found that when we use this node, when we use this option, the 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 work of snort is more consistent. Okay, so we run snort. Let's go back to mininet. I don't need ping. I am going to do the same thing as before. Run server on host 4 and then run a client on host 1 that tries to download this file from the server. Okay, the information was received. Let's go to terminal 1 and see. Here the controller received a message that says data leak via TCP, and then it has information: where is the destination and where is the source, what is the protocol. All of this information the controller use or the application use to block any future traffic. So now we see this message here that says um, any traffic from source 40 to source 10 to destination 10 protocol 6, which is TCP port 88, dropped. So I cannot send any data from the server to the hosts on this port anymore. It's blocked. Why? Because Snort detected data leak. Somebody is trying to send secret information. Alright, so again, this is another example. So it's not based on rate. The previous example was based on rate of packets. We have larger than normal rate will block. Here we detected secret information being leaked, we block. Okay, Um, so this is another example. So somebody would say, but the data was already leaked. The data was already sent. This is after the fact. We're blocking after the fact. This is just to simplify the process and illustrate how IPS work. IPS, in this case, a combination of Snort and the controller. In reality, a file can be buffered. So when IDS looks at files, it will buffer them. It will buffer all the packets until maybe all the file is being looked at, and then we'll pass it. Right. So here we didn't do that. To keep the application simple, the data itself has been passed already, but any future data will be blocked. Right. So this is just for simplicity. Um, that's to explain if somebody's keeping an eye on these things and say, hey, but the traffic is already the data is already leaked. Yeah, just in this case we're just testing, or we're showing how the two can work together, IDS and SDN. One of the questions in the deliverable is to try to use UDP rule to um, to do the same thing. So what if I am downloading the traffic using UDP instead of TCP? You can use NC with UDP. I'm gonna let you experiment with that. Now, task 5, we're gonna do something similar, but now um, blocking websites instead of content of files. What if I'm not happy with certain websites and I want to block any website that says it has certain words? So what we'll do, we'll go and add another rule that says um, it has the content budget in this case instead of secret. And yeah, so we'll do that. We'll go to Snort, stop it. If we don't want to wait forever for Snort to stop, we'll just give it a nudge by sending a packet or two. See here, it stopped. Great. Then we'll go edit the rules file. I'm just gonna copy this and add it. You see the two here are slightly different, right? The alert line is similar. The message is user defined. They can put any message they want. Here we're seeing packet data, content, etc., which is different than here, slightly different, right? As I said, there are so many options, so we're not gonna get into that. The ID here is they should be unique. So each one of these rules should have different ID, right? Revision, if you want to keep track of the multiple revisions of the same rule. That's all I want to talk about now. So we're gonna exit this. And what are we supposed to do? We're supposed, if we go back to the nodes, we're supposed to start snort again. Okay, and we'll direct the traffic to the console. So let's go back to the terminal and make sure that we're sending traffic to. I'm lazy, I'm going through the history, but sometimes because we have too many instructions, so the history probably long. So maybe I'll just write it down. Sudo snort the switch port that I'm looking at, this option that I need, and the direction of the alerts going to console, and I'm sending all logs to the temporary folder, and I'm directing snort to use this configuration file, which in turn is directing snort to go and look at the my rules.rules. Okay, I'm starting snort. So now let's go to Mininet. And if you look at the applications, the notes here say start an HTTP server in 4. So we're starting HTTP server using Python. So the way you start a simple Python HTTP server is by putting this command python 3-m http.server, and this is the port, which is port 80. So it's just very simple. If you ever want to start HTTP server using Python, this is the command you use. Okay, so we'll do that. Python is spelled. And the ampersand sign, just make sure that it's running in the background. If you ever run into trouble, you can kill the process. So just quickly, because I don't think we discussed that before. So if you are bothered that something is going wrong here, so you can say kill all h4 kill all python 3, so it will kill any python 3 applications that's running. In this case is the HTTP server. You don't need that unless you're somehow things not working for you. And we're going to use on the host, on host 1, we're going to use curl, which is another nice utility that will grab any web page on the server. So if I'm directing it to h4, it will grab the web server, the web page on that server. So it grabbed it, and by default, if there is nothing else configured, what will happen is that web page will consist of all the files that is in that server default directory. So what do we have in that file? What do we have in that folder? We have actually the application, the files that we created. One of them is called budget.txt. So budget.txt, the word budget is the one that I'm looking for. If I am downloading a web page that has the word budget, I should send an alert. Snort should send an alert. So yes, it did. So here we have an alert, attempt to visit a dangerous site. So based on the rule that we wrote. So great, because it detected this word budget and it created an alert. That's what we need for, that's conclude the lab, right? So what we need else to do else is to we didn't send an alert, this alert to the controller, right? We just looked at it in the console. So if we send it to the controller, will the controller do anything about it? No, because the controller is not doesn't it handles two messages. One, the DOS, and the other one was the leak. It doesn't handle this message, the new one that says um, attempt to visit a dangerous site, right? So we have seen, and I'll go back and visit the application. So let's go back and visit the application again. I'm gonna stop um, snort. So I stopped snort, and let's take a look at the application. The application here it has when I process the alert from snort, we'll see if DOS in the message, if the word DOS is variable that's defined up as the word DOS. So if DOS is in the message, it will send it will um, um, run this method, which will block. And if the leak is in the alert message, then it will run this method. But there is no reaction to the word dangerous. So if I even if I send the alerts to the controller, nothing will happen. So what I want you to do is to add or modify, I should say, modify this file so that when the word budget is received in the alert, the application will block any traffic from the controller to the host that tried to access that web page, right? So I'm gonna leave that as an exercise for you. Here we have the two terms, denial of service attack and the leak, DOS and the leak, which is what the application is looking for. So you may add another keyword, dangerous, and based on that you see. Anyway, I'll let you modify the application accordingly. Okay, so now I'm going to exit this, and I'm going to exit Mininet as well, and go to the third terminal and stop the controller. So that concludes everything in this lab, and I hope you enjoyed it, and see you next time.